In this video, we are going to talk about equations of lines. Now, when we write equations of lines, there's always going to be two different ways we can write those equations. So the two forms for writing equations, the first one is called slope-intercept form. This is probably a form of an equation that you are familiar with. But as a refresher, the slope-intercept form is y equals mx plus b, where m, the variable m here, stands for the slope of the line. B stands for the y-intercept of the line. And the x and the y are always there to represent any coordinate point that lies on the line. I'm going to leave this sentence blank and come back to that. The second form for writing an equation of a line is called point-slope form. The form of this equation is y minus y1 equals m times parentheses x minus x1. Here, again, we have the variable m, and the variable m, again, is going to represent the slope of the line, so that doesn't change. And the x1 and the y1, those also represent a coordinate point that is on the line. So what's the difference? Why would we use slope-intercept form versus the point-slope form? And here, I'm going to fill in these last sentences here. So the reason we would use slope-intercept form would be when we have the slope and the y-intercept, hence the name. Slope-intercept form. If we're given the slope of the line and the y-intercept of that line, it's smartest to write the equation of that line in slope-intercept form. However, if we're just given a point and a slope, hence point-slope form, we would use point-slope form when we have, again, the slope and a point. So the case in which you would use slope-intercept versus point-slope form is a little different depending on the information that you're given. So using this information, let's try the problem that's below this box. And the problem wants us to find the equation of a line that is parallel to this given equation and perpendicular to this given equation. So we have a few things we need to figure out. So let's start with letter A. It says find the equation of a line that is parallel to y equals 4x minus 5, and they tell us that the y-intercept of this line is 1. So I know that on my x and my y-axis, that the line that we're trying to find the equation to has a y-intercept at 1. Now, because they mentioned to me a y-intercept, looking at the two forms, you can probably guess that we're going to want to use the slope-intercept form because we're given the intercept. So slope-intercept form is y equals mx plus b. So we know the y-intercept. We're given that the y-intercept is 1. But what we need to figure out is what's the slope. So let's go back to the line we were given. The line we were given was y equals 4x minus 5. So going over to my coordinate plane, how does that line look? So the line in this situation, the y-intercept is negative 5. 1, 2, 3, 4, 5. And the slope in this case is 4, or 4 over 1. Rise over run. So I'm going to go up 4, rise up 4, 1, 2, 3, 4, and up 1, or over 1. Rise up 4, 1, 2, 3, 4, and over 1. So this is a steep line with a positive slope. And we need to find the equation of a line that has a y-intercept of 1 that's parallel to this purple line. Well, we know that lines that are parallel have the same slope because they never intersect. So if the slope of this purple line is 4, then the slope of our line, our orange line, is also going to be 4. So now we can easily write our equation to this line that is going to be parallel to this line with a y-intercept at 1 because we know the slope, we know the y-intercept. So the equation is y equals 4x plus 1. That's the equation. And then going over to my graph, my y-intercept is at 1, and I'm going to graph a slope of 4. Go up 1, 2, 3, 4, and over 1. I can also go down 4, 1, 2, 3, 4, into the left 1, because 2 negative directions make a positive. And when I graph that line, I see that the two lines are parallel. So I've successfully found the equation of a line that is parallel to the line that was given. The line that was given, again, was the one here in purple. And this is the equation of the line that's parallel to that has the y-intercept at positive 1. Moving on to part B. Now they want us to find the equation of a line that is perpendicular to the line given, which is y equals negative 3x minus 4. And they tell us that it passes through a point. Now notice in example A, they gave us the y-intercept. In example B, they gave us the point. So looking at my two forms, I'm probably going to choose point slope form because it's easiest to write the equation because I have a point and I can easily find the slope. Now you might be asking, well, how do we find the slope? Well, right now we can look at the line that's given to us. Remember, the number in front of the x will always be your slope. Okay, so the number in front of the x means that the slope is negative 3. Now we want the line that's perpendicular to that. So the slope that's going to be perpendicular to our given line is going to be the opposite reciprocal. So the opposite, if it's negative, that means it's going to be positive, and the reciprocal means that we're going to flip the fraction. So right now we have the number is negative 3 over 1, essentially. So the perpendicular slope is going to be positive 1 over 3. And again, we know that we have the point 5, 2. So that's kind of like our x1, y1. So using our point slope equation, y minus y1 equals m times x minus x1, I'm going to input the information I know. So I have y minus my y1, which my y1 in this case is 2, equals the slope. Now we already know the slope, if it's going to be perpendicular, has to be positive 1/3. Parentheses, my x is just a regular x, minus the x1, and the x1 in this case is 5. So going to my graph, if I were, I'll erase the two lines that are on there so it's not confusing. If I were to graph these two lines, I'll graph this one here first, the one in teal. So the y-intercept is negative 4, 1, 2, 3, 4. And the slope is negative 3, so if I rise up 3, I have to go left 1, up 3 to the left 1, up 3 to the left 1. I could also go down 3 to the right 1. So here's my first line. And remember, we wanted to graph the line that was perpendicular to that. We had to go through the point 5, 2. So 1, 2, 3, 4, 5, 2. And then the slope was 1/3. So we went up 1 to the right 3, or we could have done down 1 to the left 3, down 1 to the left 3, down 1 to the left 3. And when we connect those dots, we now see that we have a line that is, in fact, perpendicular to the line that was originally given to us. So let me box my final answer so it's nice and clear that this is the equation of the line that is perpendicular to the given line y equals negative 3x minus 4, and it passes through the point 5, 2. at this point in the video, please raise your hand or press pause if you're feeling confused so I can answer any questions you have. So moving to the back, we need to write equations of parallel lines. So example 1 states that we need to write an equation of the line that passes through the point -1, positive 1, that is going to be parallel to the given line y equals 2x minus 3. And then it wants us to graph both lines. So as you can see, I've already graphed the given line, and I've highlighted that in yellow. So that line is already in slope-intercept form. So it's really easy to see what the slope of that line is. We can just look at the number that is in front of the x. So if we want to write an equation of a line that's parallel to this line, we know the slope has to be the same. So the slope of the line that's going to be parallel to this will also be 2. Now as for the y-intercept, we don't know what the y-intercept is. They did not tell us. They only gave us the point, and we only know the slope. So what I would recommend doing is I would take my point-slope form. So knowing that point slope is y minus, I'll write it up here, y minus y1 equals m times x minus x1. And I would plug in what I know. So right now I know my m is 2, and I also know my x1 comma y1 is the point -1 comma 1. That was given to me. So plugging this into the formula, I am going to have y minus 1, which is the y1, equals 2, which is the slope, times x minus the x1. Now I'm minusing a -1. Remember, when you have two negatives right next to each other, they become a positive. So this formula now, the equation now becomes y minus 1 equals 2 times x plus 1. So this is the equation of the line. I could technically put that down here and graph it and be done. However, the question asked me for the y-intercept. So I'm going to show you a really neat trick. You can actually manipulate this point-slope formula, or this point-slope equation, by solving for y. And when you do that, after you solve for y, your equation will now be in slope-intercept form, and it'll be really easy to see what the y-intercept is. So let's do this. Let's distribute the 2. So now I'm going to have 2x plus 2. I'm distributing the 2, so multiplying the 2 to both terms inside my parentheses. On the left, I still have y minus 1. And last step, if I want to get y by itself, right now there's a -1 next to it, so I'm going to undo that by adding 1 to both sides. That goes away, and I'll be left with y equals 2x plus 3. So I just took the point-slope form of this equation, and I solved for y. And when doing that, I now have an equation that is in slope-intercept form. Remember, which is y equals mx plus b. And now I can really easily see what the y-intercept is. The y-intercept is 3. Or if I want to list that as a coordinate point, I would list that as 0, 3. So going to my graph, I would find a y-intercept of 3, 1, 2, 3. And I'm going to graph a line with a slope of 2. And when doing that, I have now created a line that is parallel to the original highlighted yellow line that I started out with. So down here, when they ask for the equation of the line, you have two options, which is pretty neat. You can either write the point-slope form, so you can say y minus 1 equals 2 parentheses x plus 1. That's one option. Or you can write the slope-intercept form of that line, which is y equals 2x plus 3. Either answer is acceptable as being the equation of the line that is parallel to the line that was originally given.